This next chapter goes over querying data, and that's not completely new, so we can build on some of the skills that you already have used. You've done a little bit of selecting by attributes, which is a query. And so we're going to look at kind of the reasons that you query, the functions of a query, I think she calls it. So one of the major reasons to do a query is to select some feature that's of interest to a study, or to create a small subset. So for example, we had a shapefile showing 7 years of auto theft in Eugene Springfield, and that was a huge amount of data to analyze, and so it made a lot more sense to kind of look at it with different attributes in mind. So day of the week, time of day, excuse me. And so it was a lot easier to kind of create these subsets. Once you have subsets, the other reason to do that is to look at the patterns or the relationships. And in geography, when we're looking at spatial relationships, we're kind of thinking about, are they clustered? Are they linear? Are they kind of randomly dispersed? And we also want to look at what they're near. What other associations are there? So could you be looking at crimes that are near shopping malls? In fact, some of the most common break-ins of cars, or the most frequent break-ins of cars, were at the Cinemark theater, because people who parked their cars would leave them for at least a couple hours while they went into a movie, and so that seemed to be a location where once Springfield PD did some analysis, they began to put in more patrols in that area. So when we're looking at this idea of selecting an area of interest, we've done that with points. You can do that with lines. You could do that with polygons. And often we're looking at an attribute in typically a vector data, either a shapefile or a feature class, sometimes even a coverage. But you can do that selection based on one of the attributes. So in the geospatial chapter, we'll be looking at snail habitat, and we'll be also using some of the attributes related to vegetation. So the cover type in this case equals some kind of value called TAA, and sadly they don't talk about what the TAA stands for. But so if you do a query, cover type equals, you would get a selection of those features that meet your query. And then once you have that query, you begin to look at that pattern. You know, is it in one section over another? What's the distribution densities? And then there are functions in ArcMap in the toolbox that let you actually look at the statistical relationship between different values of data, or different selected data. Once you have them selected, then you can isolate them out as a separate feature class, or as a target area for some other kind of work. So here's the example of using two different attributes within the same feature class. So the tree size equals L, and the density equals A. So what I'm looking at are two kinds of categorical data. So there is some kind of value somewhere that says tree sizes L are between some either height or some circumference and another circumference, and the density type is also based on some kind of coverage. So this is a density type A. This could also be then thought of maybe as ordinal data, where the density, highest density is A, medium density is B, but you'd really have to have some metadata to tell you what those are. So if I am selecting from two different fields, tree size equals L, density equals A, I'm going to limit my selection. What if I had used the OR operator? Because when we think about selecting, that's often how we how we think about things is that we're going to use an OR operator. So in this case, if I said from one attribute field tree size equals L, or from the other attribute field tree size equals A, in reality I would select every single attribute in that feature class. So you have to really think about sometimes what it is, not sometimes, all the time, what it is you're trying to select for. So there's two types of queries that you're going to do, actually probably three. There is an interactive query, or it's more of an interactive selection. So I guess there's several types of selections, but two types of queries that we're going to work on in this chapter. One is the attribute query, which you've already done quite a bit of. The second is a spatial query. What if I have two different feature classes? I can't select an attribute of one based on the attribute of another because they're in two different tables. The attribute queries are done within the same table, so I can select multiple fields. I could choose population field greater than 50,000, income field less than 20, male over female greater than 50%. So I could do this and that and that. But we're working within one feature class. If I want to look at the relationship between two different feature classes or three different feature classes, I can do a spatial query. So for example, if I have a house feature class and I have a school feature class and I'm a realtor and I want to be able to, my client wants to only look at houses that are within a mile of a school, I can use a spatial query for that. Or if I want to be able to look at culvert and fish passage and maybe potential flooding, I could look at those culverts that were within a certain distance of another feature class. I'm going to try something here. I don't know if this is going to work. Yeah, there it is. So this only has one feature class involved. This has multiple feature classes when it doesn't have to, but well, yeah, it does. If I'm doing a spatial query, I'm looking at the relationship of one feature base to another. So with a spatial query, I have to have at least two feature classes to work on. And the format we're using is called SQL, Structured Query Language, and this is a very specific set of code or syntax that's used for queries, and it's used in many, many different database or other applications for querying. So you can save your query. So often I will copy a query and paste it into my documentation. And so this is really where it starts to be very important for you to keep a notebook or a log as you work, because you may try 3 or 4 different query syntaxes, and sometimes it's hard to remember what you just tried. And so being able to copy and paste a query onto a document and record if that's the answer you got or if that's the answer you wanted. And then sometimes I want to use that one again. So you can save them, you can reuse them, and usually they are case sensitive. So we're looking for field names that are exactly, if it's all caps, and it's looking for a field name that's all caps if I'm working on that, if I'm trying to use a text predominantly. So we're using in attribute queries, you're using those Boolean expressions of and or. Those are the ones that you commonly think of. And so here is an example. If I have one of her questions on the review questions is about doing queries from a dish of mixed candies, and then she has another one that's about schools and number of A and B students, and it will make your head kind of think a little bit about that. But if I have a circle or a set, so think about that circle A as being a population of people over the age of 50, and B is income 20,000 or higher. Where those two overlap would be where the people that are over 50 also have an income of 20,000 or less. Now, I don't know here the ages of these people, and I don't know the ages of the people in A, but I do know where they overlap. That is where both conditions are met. If I were to use the OR operator, the A would be, the A circle is the people over 50, and the B circle is the people with an income under 20,000. If I use OR, all the data is selected. And I think that was the same example kind of up above. So there are other operators that we use. There's the A and the B, the A or the B. The A not or B means kind of just the elimination of A and B where those overlap, and the A not B is just the A without that section. So being able to visualize what it is you're looking for sometimes in a query is really helpful. So the logical operators we use are greater than or equal, not is the double symbol here, greater than and equal, greater than, less than or equal to. And then the Boolean operators are the AND, or, XOR, or not. So when we do a query, when you perform a query in ArcGIS, the query table fills in select from, and then you double click the layer, and then it puts in the word where, and then you have to add a field. What field are you selecting from, and then your logical operator, and then whatever your condition is. So for example, I can select from cities. So cities is my feature class, where pop 210 is my field. And remember, I couldn't write this as 210 pop because ArcMap won't let you start a field name with a number. Pop 210 is greater than or equal to 50,000. So I've got my feature class is where I'm selecting from, and then where is my field, my operator, and my condition. Here I'm going, one field is pop 210, greater than or equal to 50,000, and is my other logical or my Boolean operator, and male is less than 50. So here I'm looking at two different fields within the same feature class. So if I chose a query that said name, so let's say I'm looking at states as my feature class, and the field is name equals Alabama and name equals Arizona, what would my result be? Bum, 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 bum. Yes, if you said your result would be the selection of just those two states within your state feature class, you would be absolutely correct. Number two, if I said name equals Alabama or name equals Arizona, what would my result be? Again, you are correct. It would be every single state in my feature class. I'm just amusing myself all to heck here today. The next one is not name equals Alabama. So this would select everything except Alabama. Now, interesting enough, if I said name equals Alabama, it would select only Alabama, but then in the attribute table, I could do a switch selection where it would take everything except what I selected. So that's another way to do a not. So if I want to do not name equals Alabama and not name equals Arizona, again, you are correct. I would get everything except those two states. And then the second one, I've got two different, comparing two different fields. Males under 5 is less than females under 5. And then the last one is kind of a cool wild card. you can use the like function. And if you are using, well, I'll show you that in a minute. Here we go. Here's the like operator. Oops, let me go up here. So the like operator is a little tricky, and if you have an older, if you're looking at an older copy of her book, she uses a personal geodatabase, and a personal geodatabase has a different syntax than the file geodatabase or a shapefile. So if I want to find all the Democrats in a list, so here I've got this attribute table, and it's showing me the letter for what party they're affiliated with. If I just say name like %, and that means anything that comes before, ignore it, and look for this paren, d paren, and anything that comes after it, ignore it. And so it's going to find all of the D's because it's in that parentheses using that wildcard. If I do the name like new with the %, again, I would find New Hampshire, New York, but I would not find Newcastle or Kennewick because these have a space. So this says new space paren, so it's looking for anything with a space. If I took that space out, I would be able to find Newcastle. I don't think I would find Kennewick, but I'd have to go back and play with that. Again, depending on what type of data you're working with, if you have a shape file, the % works, and if you're in a file geodatabase, the % works. And actually, I have to double check that because make sure that's still true. And then the asterisk works for a personal geodatabase. Yes, I'm correct. So, and the way to tell if you're in a file geodatabase is it has that as an ending, and a personal geodatabase has, I think it's an MBD. Hold it. Yes. And as I stated earlier, and personal geodatabases are older. They don't hold as many records, so they're a little smaller. They also require access, and so some computers really don't function with them very well. And with a file geodatabase, you can have kind of multiple editors. And I may have lost some of my size right here. Make it a little bit bigger. Okay, so again, this part won't be new to you. So when you're going to select by attribute, I think predominantly you've been doing that from the table, but you can also do that from the main menu bar. You can choose selection, select by attribute, pick the feature class or the shapefile layer that you want to select from, choose your field, and then choose your operator or your logic, and then your condition. So here, pop 210 greater than 700. I don't know if that's 700,000 or 700 with decimals. I hope it's 700,000. And then again, using the logical operations again from two different fields, because I'm using the AND. You don't have to have two fields to use the AND. You could also limit smaller this and greater than that from the same field. So that should look pretty familiar to you. The not function is a little tricky. So if I want to label all the states except Texas, it would make sense to me to start with state name not Texas, but that doesn't work, so it's not, and then you put your Boolean first is not state name equals Texas, or the double greater than less than sign. And again, you can do a reverse select, and I had to use this the other day in the labeling tool because I had a feature class that had GPS point locations for different floors in the center building, and I only wanted to label one floor at a time. So I had to do a query by floor and then have just those labeled. And you did a little bit of that kind of labeling in the third week with the price chapter. So the second type of query is using a spatial relationship, and there are three general categories of spatial relationships that ArcMap works with. One is an intersection, second is a containment, and then there's the proximity. So for the intersection, it's, does a part of a line or a polygon cross whatever feature I'm looking at. So do two polygons share the same boundary? Does the road cross over this, what is this, an aspen field or something like that? And I think this is in your textbook. Containment would look, is that polygon inside a unit? So this would be contained. This would be intersecting because it's not wholly contained. This section of, I don't know if that's a road section or a river section, but these would be contained, whereas this piece of road would not be contained. Proximity lets me select all of the roads that are within 50 feet of an aspen grove, or all of the culverts that are within a tenth of a mile of a road. That proximity becomes really important because I can't always trust that who collected my GPS points for my culverts and who created my roads, that those are actually going to line up exactly. And if I want to find all of my culverts that intersect a road, I'm going to miss a lot of them. And so using that proximity allows for some scale difference in data collection and mapping. There are so many spatial operators, and it gets really confusing within those three types. So there's intersect, intersect within a distance, contain, completely contained. There's the CLEMENTINI option, which I've never used, but I'll tell you what I know about that, which is not all that much because I've never used it. So often there's a couple that I use pretty consistently, and then if I try different ones and they're not giving me the results I want, then I know, to try another. So some of this is just a little bit of learning which tool works for you. But basically intersecting or within a distance, contained or completely contained or within, those are kind of the options. And I think one of the differences, this polygon could be contained, but this polygon would be wholly contained or completely contained. So a little bit of hair splitting, I think, with some of that. So this is the explanation from the Price set of slides, that there was a discussion about if you have a line that's a border, a boundary between two places, is that real, or is that's really not a physical thing on the landscape, it's a location. And so is that boundary inside or yeah, so they came up with this Clementine that eliminates, would not select the Rio Grande because the Rio Grande is actually on the border, the boundary of Texas. And I'm sure that was invented and developed because there was a need to do that. I haven't run into it. The other type of selecting data is through an interactive selection tool, and you can select by rectangle, polygon, lasso, circle. One thing you want to do is to make sure that you, if I were trying to get all of the counties in a few states, I would want to make sure that I had set counties as my only selectable layer, so that as I use my rectangle or my polygon tool, I'm not selecting all of the data that is within that selected area. And then you'll practice a little bit with the select from a radius. One thing to really check when you're doing selections is this introduced idea of selecting from already selected features. So for example, I selected with my selection tool, the rectangle tool, I grabbed the US, Canada, and Mexico, and those were selected. And then I wanted to know of those areas which of them had a population greater than a certain number. So I had to go to my county selection, because that's the or country selection. That was the feature class I was working with. And then I chose from the method was to select only from the current selection, and then I could choose my selection there. So that gets pretty tricky. Here is an example where I used both the attribute query and then the spatial query. So I selected all of the earthquakes in the United States that had damage greater than a certain value. So again, my feature class, my layer was earthquakes. I wanted a new selection because nothing had been selected yet. The damage was my field. I used this operator, and then I think I typed in a value here. And so what I saw with my selection, there were 4 earthquakes that met that first criteria. Then I wanted to look at their association with cities. So I opened up the selection and chose select by location. And here I wanted to select the earthquakes from those 4 that I had already selected. So the selection method here was select from the currently selected features in the earthquakes, and then I wanted to know their association to major cities, and I also wanted to know a distance of 5.55 miles, and that was a critical value that I needed. I just made that number up. Anyway, so here we go. So when I did that and applied that, only 2 of my earthquakes met both criteria. And you could do this either way. I could select all of the earthquakes, create a new selection, all of the earthquakes that are within a distance of 5.55 from a major city, and then from that select from the selected those that are damaged or has a damage of a certain value. So sometimes, and I just did this about 5 minutes ago testing something, I kept trying to work on a selection and did not realize I already had some selected feature, or it was set to from the selected features, and so there were none that met my query. So sometimes you have to go back and double check that you've got the right method chosen. Okay. The last idea is once you get these features selected by multiple means, sometimes you'll do 6 selections within one problem. I want to save those, and so she talks about saving them as a layer, and I do not like that method, and I'll talk to you a minute about why I don't like that method. But you can isolate those selected features, export them as a separate feature class. You can save them as a layer as she suggests. She also introduces clipping and erasing, which we'll get way more into in geoprocessing, but I'll just talk about those very briefly. So if you have a selection, you can go to selected records and save as a new layer. This is not a layer file. This is not a layer package. This is just a visual copy of your selected data. And it will come up on ArcMap as, let's see, what did it call it? There's too many to look at here. Oh, it went away. It calls them a selection, which is new. So if I were to take those earthquakes that I have now, and I named them very badly. See, I'm just showing you what not to do. So I can do selection. I don't know if you can see that. Let me move that over here. Oh, you still can't see it. Let's move it up there. Oh, come on. Let's try that. Create a layer from the selected feature, and then it says export output selection. So that's how that is. I haven't made a new copy of the data. If you look in your feature data set or your geodatabase, you don't have another copy. You have just made a visual copy of that. The problem is if I do any analysis on that, it does the analysis on the entire feature class that it's a copy of. And so we had some data. We were looking at crime data, and we had these really weird, this was a few years ago before we realized that, we had some really weird values that were created later when we used the data set again that were not intended. So I'd never do that. It's easier for me to create export as a new feature class or shapefile that has a unique name that indicates what my selected values represent. So she also talks about clip. So I used my interactive selection to select the state of California, and I wanted to know, I just wanted to get the earthquakes that were in California. And I happen to have teacher salary on my as the name of my state layer because I had used that on my map. So because only California is selected, when I do my clip, that is the only clip feature that it will look at. And a clip kind of acts like a cookie cutter. It just takes everything that is inside or completely contained or even on the borders and edges and puts that into a new feature. So when I run the clip tool, so I get that out of geoprocessing clip, I'm going to choose the earthquakes, the state feature class, and then I have to give an output. Now, again, I was being pretty lazy, and this just went to my default geodatabase. I did name it Quakes in California, but you really need to start documenting where did it go and what did I call it, because this may not be the output that you want, and you may need to try another method. And so when I was finished with that, I got just those states or just those earthquakes in California as a new feature class. Now, I did that again with the roads. So I chose to clip the roads by my selected California, and what it did, this demonstrates the cookie cutter idea much more clearly. It just cut off those roads at the California border, and so I have these truncated road features. The erase is just the opposite. You can't get to the erase from the geoprocessing. You have to go into the toolbox. It's under analysis overlay. Again, we'll do more of that later. But if I say erase the major roads from California, I have no more roads in California. So just two different ways, and I'm not really sure why she introduces those right now, but she does. Buffering, again, I can access the buffer tool from the geoprocessing menu, and if I had let's say I want to be able to buffer the state of California with like a 5-mile buffer on each side to see if there's any earthquakes that would be close enough to the border. I don't know, I'm making that up, but that could be a reason. Then I would end up with a new polygon called California Buffer, and it would have a 5-mile edge added to the California Buffer. So anything I select, I could buffer it that way. In the third chapter that we worked on in Price, we looked at definition queries, and this is another way acts a little bit like a layer where it just shows you the data that you want to look at. So I have all of the states in the United States in my feature class, but I just want to be able to look at Oregon and Washington. So in the layer properties, so not in the feature class, but in the data frame layer properties, I set a definition query to show only Oregon and Washington. And then all the other data, the roads, the rivers, volcanoes, earthquakes, I showed those to have a clip extent to my Oregon and Washington states. And so I went through that process, and I think there was multiple videos showing how that came about. For this chapter and the next chapter, I have included a problem-solving guide. And so, again, you really should be keeping notes at this point. One of the first things is to kind of read the question and make sure you understand what your outcome is. Like, so what do I want to end up with? And then sometimes work it backwards. In your tutorial and in the exercises, each step is something you've already done. And so you may want to highlight those sections in the text so you know where to go back and review that. I often have to rephrase the question. I pull out the nouns, the verbs. I try to figure out which data layers she's asking me to look at. If you're using the wrong data set, if you're using PriceE7, you need to go and download the correct one from the syllabus. And again, the tutorial is to kind of help you reinforce the reading, or the exercise help you reinforce the tutorial. It's really important to write down the process that you used. What did you enter as your search? What did you enter as your logic? What was your condition? If that didn't give you the results you wanted, it's easy to try another iteration, but you need to record what you did and then what your outcome was. And then if you're stuck, you can ask for help, but you need to be able to talk about what you did, what you're trying to do, what you've already tried. This is really the important part of this entire course, is the problem-solving process. I can show you where to point to things, but you really need to be able to look it up in Google, try to find it on your own, struggle with it a little bit, try it a different way, and then when you come for help, you can give me a beautiful video that shows me what you're trying. Things to check. Did you clear your selection? Maybe you're trying to do another selection and it's already selected. Did you check to see if you have new selection or select from the selectable layer? So as I wrote that, I completely forgot that when I was trying to demo something a little earlier. Sometimes setting the selectable layer is really important. And then, do you know what you named your file? Do you know where you put it? Some of these exercises and tutorials, the first time I ran through them, I had to go through them 3 or 4 times, and if I didn't write down what I had done, I was kind of doing that, what is that, definition of insanity, trying the same thing over and over. So again, this chapter is much more involved than the first 3 chapters we worked through, or the first 4 chapters. Those were a lot like 151. Those of you who are not in 151, you've had a really steep learning curve. So just keep a lot of notes.